Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. So as you all already know that our exam is coming nearby, and those who are preparing for this year's exam for the ISS examination of 2026, I would recommend you all to re-revise whatever you have, whatever sources you are doing that. Keep your sources very limited and re-revise them again and again in order to get good marks in your examination. And those who are preparing for 2027, they can also watch this video. This video is both for 2026 aspirants and 2027 aspirants as well. This is a revision for numerical analysis for both of them. If you have completed the course of numerical analysis, then this class is for you. And if you haven't, then you can go back to our playlist of numerical analysis where I've explained everything in very much detail. And then you can come back here for your practice questions. So what you should do here is you can watch the video in 1.5x speed, and you can see you can stop wherever the question is given and solve it on your own. And as and when you will be able to solve it, you can check the answer with our solution, and you can check the tricks also with our solution, that what should be beneficial, whether our trick is beneficial or your one is beneficial, which is saving your time. So let us begin with today's lecture. With the question, as and when the questions will come, we'll be discussing the concepts on that as well. So I'm not telling you one or two concepts beforehand because there are ample number of concepts in today's lecture video. So we'll be telling you concepts as and when the question will arrive. So first of all, let us start with this one. So this is the question. This is the first question for today's lecture. Here they have given us all of the questions that we are doing are the PYQs, and they have been repeated multiple number of times. I have taken just one of that kind so that you all can practice it with me. So in here they have given us the formulas for applying Lagrange's interpolation formula. First of all, they have given us the values of f's. F naught is 8, F1 is 11, F4 is 68, and F5 is 120. These are the formulas for numerical analysis. Now, what is Lagrange's formula? Lagrange's formula for interpolation, suppose we have to find out the value of f of x. Then Lagrange formula is f of x naught into x minus x1, x minus x2, and so on upon x naught minus x1, x naught minus sorry, x2, and so on, plus f x1, x minus x naught, x minus x2, and so on upon x1 minus x naught and x1 minus x2, and so on. Those who already have learned the formula, they know this formula. I'm not writing it in detail. We'll be directly applying that. In examination, you shouldn't write the formula for solving. First of all, you will directly write as and when you practice, so you can directly write the statements. So the value of x here that has been given to us is f2. This is the value. So f2 is nothing but fx naught. Fx naught is 8 into x minus x1, which is x here is 2. So 2 minus 1. x1 is 1. And then 2 minus 4, and then 2 minus 5 upon 0 minus 1, 0 minus 4, 0 minus 5, plus the second term. Here the term will be 11 fx1. Here will be 2 minus 0, 2 minus 4, and 2 minus 5 upon 1 minus 0, 1 minus 4, 1 minus 5, plus the third term, which will be f4, which is 68. Then it will be 2 minus 0, 2 minus 1 and 2 minus 5 upon 4 minus 0, 4 minus 1, 4 minus 5 plus the last term is 120 into x, 2 minus 0, 2 minus 1 and 2 minus 4 upon 5 minus 0, 5 minus 1, 5 minus 4. On solving that, we will be getting our answer as 8 into 2 minus 1 will be 1, 2 minus 4 will be minus 2 and 2 minus 5 will be minus 3 upon minus 1, minus 4, minus 5 plus this will be 11, 2 minus 0 will be 2, 2 minus 4 minus 2, 2 minus 5 minus 3 upon 1 minus 3 and minus 4. Then the third term is 68 into 2 into 1 into minus 3 upon 4 into 3 into minus 1. Then the last term will be 120 into 2 into 1 into minus 2 upon 5 into 4 minus 4, sorry, plus 4 only into 1. So on cutting and subtracting, see here 3 negative sign are there, so it will be 4 2s are 8, so it will be minus 12 upon 5. Here all are positive sign because this negative negative will get cancelled, so it will be 3 getting cancelled with 3, 2 and 2, so it will be 8 plus 11. Here it will be 3 will get cancelled, plus and minus get cancelled, 2 2s are 4 and 34. So it will be plus 34. Then it will be minus because only one sign is given. 2 2s are 4, 5 24s are. So it will be minus 24. Adding and subtracting all of them, it will be 10 plus 11, 21, 21 minus 5. 21 into 5 minus 12 upon 5 will give us 105 minus 12 upon 5. 105 minus 12 upon 5 will be 93 upon 5, which will be 5 ones are 5, 43, 5 eights are 40.6. So it will be 18.6, which is our option number C. So till 18 also, if you calculate, you will know that the answer is our 18.6. So this required a lot of time for us. Now the trick here is that you can use you can use only 3 digits or from any of them, 0, 1, 4 and 5, only 3 of them or 2 of them, then also your answer will be similar instead of calculating for all the own. And here you can cancel from here only, no need to write it here because I had to do it to show you, so I have written it separately. You can cancel from here only, plus minus, adding and subtracting, no need to write it again and again. Okay, now moving forward to a formula based question. This. So this is also your PYQ. Here they have given us the the relationship between Shepherd formula and inverse backward formula, a backward interpolation formula and E. So Shepherd's formula or Shepherd's term can be written as, when we say triangle, it will be minus half into E. It will be delta e raised to the power minus half. And when we talk about this, it will be inverse, backward uh, interpreter into e raised to the power half. This is also Shepherd formula. So you have to know, or you have to consider both these formula. These are very important, and there is a distinct difference between both of them. So here they have given us inverse. So as and when we see this formula, alpha will always be 1 in both the cases, in inverse triangle or in forward interpolation symbol or backward interpolation formula, alpha will only be 1. So these two options will get cancelled on their own because alpha is minus half and half. So 1 and half. Now we have to see the next one. Since it is reverse or backward interpolation, so we have the positive sign here. So our option number B is the correct answer with the positive sign of half. This you have to remember by heart. If you know the theorem or the derivation or the relationship, then you can quickly just guess it, just know it and take it. This won't take even a second of yours. And if you don't, then I will recommend you to leave this question instead of doing the guesswork. Now moving forward to this question. Here they have given us that suppose we have been given t naught goes from 0, t1, t2, and if f is a continuous function. Here they have given f is a continuous function. And FTI givens are for all the values of lies between 0 and 1. Which quadrature formula is applicable from 0 to 1? So first of all, when we are talking about continuous function, then it may take any number of equal or unequal intervals, and that too the continuous function is saying. So these all those rules. First is trapezoidal rule. Trapezoidal rule can be used for all equal and unequal intervals. Simpson's one-third rule can be only used with where the sum is a multiple of 2. And here it is 3/8 is multiple of 3. So here no such is given, and we are given that it is the continuous function. That means it can take any value. It can be equal or unequal. So our answer here would be trapezoidal rule, which is our option number A. Whenever there is a continuous function, only trapezoidal rules can be used. Whenever there is a continuous function with the intervals are the multiples of 2, then it is Simpson's one-third rule. Intervals are the multiple of 3, then it is Simpson's 3/8 rule. This you have to know. And if you don't know, then you can rewatch our lecture videos in which I have explained very well how and when they are used. Now let us consider trapezoidal rule only. Here we have been provided with trapezoidal rule question. This is very easy question. People will go and try to solve them in the examination, but if you don't read it very well. So here they have given us the function y is equals to x square plus 2x plus 3, and y0, y1, y2 are the values of y at x equals to a plus 2h, and a plus h, a plus 2h respectively. What is the value of this function? So in trapezoidal rule, whenever we consider a trapezoidal rule, we consider it like this. Formula for trapezoidal rule: x naught plus nh up y dx will be equal to h by 2 into y naught plus yn plus 2, all the ones lying in between, y1, y2 and so on till yn minus 1. Okay, this is a trapezoidal rule. But here only 3 y's have been provided to us: y0, y1 and y2. So if we put it here, y0, y1 and y2, so it will be h by 2 y0 plus the last one is y2 plus 2 into y1. This is our formula directly. There is no need to use this function. This is just to distract you from the main question. And the answer is option number A, y0 plus 2y1 plus y2. y0 plus 2y1 plus y2 h by 2. This is the direct formula presentation of trapezoidal rule. They have just given you the things so as to confuse you and waste your time. Instead, if you read the question once and for all very carefully, then you will be able to answer the question within no time in the examination. So now we'll move forward to another concept question. This one. This is Shepard's relationship again. And if you know the relationship, you will be able to solve it within no time. And here we'll be using the relationship. So first of all, the relationship is mu square is nothing but 1 upon delta square by 4. This is the relationship between mu and deltas. So if we put this in the value, so we have been given 2 under root 1 plus delta square mu square. Instead of mu square, I am keeping the value of this mu. So it will be 1 plus delta square upon 4. So here if we add them, then it will be nothing but delta square plus delta raised to the power 4 upon 4. And if we multiply it, it will be 2 under root 4 plus 4 delta square plus delta raised to the power 4 upon 4. So we have got this in under root problem. So upon 4 can come out of the root and will be 1 upon 2. So this will be 2 upon 2 under root of 4 plus, I can write this as 2 square plus 2 into 2 delta right, and plus delta square. Here delta square will come, whole square. So here we can see this is a square plus b square plus 2ab, right? You can see the formula. So 2 and 2 will get cancelled and we are left with a plus b whole square. What is a and b here? A is 2, a is 2 and b is delta square. Then this whole square and this under root get cancelled and we are left with 2 plus delta square. And yx has been given to us. So yx. Now delta square. Delta is nothing but they have also given us to us half minus 1 upon e raised to the power half. And delta square will be equal to e minus 1 upon e plus 1 upon e minus 2. This will be the formula for delta square. Now putting that here, it will be 2yx. I am multiplying yx plus eyx plus e raised to the power minus 1yx minus 2yx. Now this plus 2yx and this minus 2yx gets cancelled and we are only left with eyx. Eyx is yx plus 1 plus e raised to the power minus 1 yx is yx minus 1. So this is our final answer, yx plus 1 and yx minus 1, which is our option number C, the correct one. The only difference between these two are here it is minus sign and plus sign. This only we have to see, rest other is correct. Now there are multiple number of ways. If you don't know the formula, you can directly apply delta square and mu square and put it here. Then also your answer will be the same thing. And here also the answer will be the same thing. That one will be a longer one. And this one, since we know the formula, this is the shorter one, or the it takes lesser time than that one. So if you know the formula, that is the trick of solving the Shepherd's notations for questions. So that's how you can solve it, saving the time for other questions that require more of your time. Okay. Now moving towards the last question for today's lecture. Here they are. They have given us this table. Okay, and we'll be dealing with this table by forming one more table of our choice. So here they have the question is for Newton-Gregory's forward difference interpolation formula and Newton-Gregory's backward difference interpolation formula. The table for both of them will be one only. but the formula is different. Let us discuss how. So first of all, let us make the table. So here we have been given the values of u's, and here we'll be taking the values of fx. Okay, and from here we'll be taking the differences. We'll be mentioning the differences simultaneously. So u are 3, 4, 5, 6, 7, 8, and 9. The values of u are 4.8, 8.4, 14.5, 23.6, 36.2, 58.52.8, and 73.9. Okay, all of them are correct. Now we will take the first difference here. So first difference will be, I will subtract this from this. So 8.4 minus 4.8 will be 3.6. We'll subtract this from this. It will be 14.5 minus this is 6.1, 9.1, 6, 2.6, 12.6, 12, 16.6, and this will be 21.1. Now we'll take the second difference. We'll keep on taking the difference up till the constant term arrives. Okay, after that we won't have to take. So 6.1 minus 3.6 will be 2.5. Here it will be 3.0. Here it will be 3.5. Here it will be 4.0. Here it will be 4.5. Now we all can see the difference. The next one will be the constant. So we are finding delta Q here. So it will be 0.5, 0.5, 0.5, 0.5. Now Newton-Gregory's first interpolation formula. First of all, we'll calculate the first one, forward interpolation. I'm making you do this in very detail. So first of all, we'll calculate the value of u. So we have to calculate a plus nu is equals to the term for which we have to calculate. In the question, they have given the term for which we have to calculate is 2. So u 2. So it will be 2. A is the first term. The first term was 3. So in place of a, we can write 3. In place of n, which is the number of terms, we can write how many terms are given. N is the differences between all of them. So 3 plus 1 plus 2. So only one number of difference is there. So it will be u only. So u will be our 2 minus 3, which is minus 1. So we'll take this. The Newton-Gregory's forward interpolation formula is, if we have to calculate fx, then it will be f x naught plus u delta f x naught plus u minus 1 upon 2 factorial delta square f x naught plus u minus 1 u minus 2 upon 3 factorial delta cube f x naught. Only cube that we are calculating. After that we won't be calculating. So if we calculate for fx here, so fx is f2 only. So delta fx naught, the first one is this one. First is 4.8. So delta fx naught is 4.8. So we'll take it here as 4.8. Now plus u. U is minus 1 and delta fx naught is first difference of delta is 3.6. So it will be 3.6. Then u and u minus 1. Minus 1, minus 1, minus 1, minus 2 upon 2 factorial is 2 into 1. Delta square fx naught. So the second difference, first one is 2.5. So here we'll take 2.5 plus minus 1, minus 2 and minus 3 upon 3 factorial. 3 into 2 into 1 into delta cube fx naught. The third difference is 0.5. So we will be taking 0.5 here. Now we'll calculate. The first difference is 4.8 minus 3.6, and this 2 and 1 get cancelled and we'll getting plus 2.5. Here it will be minus 3 to 1, minus 3 to 1, only minus sign remains, so minus 0.5. 4.8 minus 3.6 is 1.2. 2.5 minus 0.5 is 2. So it will be 3.2. That is your answer. So let us see which option is the correct one. So it is our option number B, which is 3.2, the correct answer. Okay, this was your forward interpolation, Newton-Gregory's forward interpolation formula. Now if we have to calculate Newton-Gregory's backward interpolation formula, the formula reverses as well as the value also reverses. So how are we taking backward interpolation formula? Here we have to calculate for u 8.5. So our 8.5 will be equal to a, which is 3. Not 3. It will be, here a will be the last term. Last term is 9. So 9 plus 1 into u. So here also, here u is equals to minus 0.5. Now Newton's backward interpolation formula is fx equals to fxn, the last term. There we were taking the first term, here we will be taking the last term, plus u delta fxn plus u plus 1 upon 2 factorial delta square fxn fxn plus u plus 1 and u plus 2 upon 3 factorial delta cube fxn. Only we have till delta cube, so we will be taking that. Now we have to calculate for f 8.5. So the first is fxn, which is the last term. So this is 73.9. So we will be keeping this here, 73.9 plus u is minus 0.5, and delta fxn here is, the first difference is 21.1. So we will be keeping it here as 21.1 plus minus 0.5 into minus 0.5 plus 1 is 0.5 upon 2 factorial, 2 into 1 into delta fxn here is 4.5. So it will be 4.5 plus minus 0.5, 0.5 and 1.5 upon 3 factorial, 3 into 2 into 1, and the last one difference is 4.5. So we will be taking 0.5. Now we just have to calculate here. It will be 73.9 minus. So it will be 1055, 10.55 with the minus sign, plus here minus sign will come for sure. So it will be 25 into 45 upon 2. Minus 0.56, 2.5, and here also we will be taking 3 5s are 15, so it will be 0.5. Now this will be 6.625 divided by 2. 625 divided by 2 is 0.5, and 1, 2, 3, 4. Four more symbols, 1, 2, 3, and 4. So it will be minus 0.03125. Now we just have to subtract all of them from here. If we subtract 10 from here, it will become 83, 82 point something, 83, because point 0.9 is there. So 83.35. And we have to subtract rest other. First of all, let us see what are in the option. So if we are here, we all see there is, sorry, it will be 63. We are subtracting, not adding. 63.35. Here the option includes 62, 64, 66. The nearest one is 62, because from 63 also we have to subtract some of the numbers. Maybe they are in points, but we have to subtract that. So we'll be approximately going to 62.75. No, it will never be greater than 63 because we are subtracting. So our option number A is the correct. You don't have to calculate for all of it. You just have to see the options and you can mark your answer. So this was your questions for today's lecture. I hope that you understood all of them. Now, those who are preparing for 2027 ISS examination and haven't started yet, then you can enroll us on our website. And we are taking admissions and enrollments from now only. And our classes will begin from 15th of July 2026. And we'll be taking very limited number of students because we are very focused, and we'll be interacting with one-on-one with each and every one of you. So all of you, those who are interested, can ask us all your doubts regarding our batch of Lakshya 2027 on the number given on the screen. And for today's lecture, those who have understood, well and good. And those who haven't, you can ask us on your comments section, ask us your doubt, and we'll be solving them simultaneously. All the best. Thank you.